to start by drawing a triangle that should look similar from last time. I'm going to have x, y, and a hypotenuse of 1. Alright, so if I wanted to find sine theta, I'm not asking for the angle, I'm just asking for the ratio. So it's opposite over hypotenuse, which simplifies to just y. Cosine theta, that's adjacent over hypotenuse, which simplifies to x. Alright, now let's throw in some Pythagorean theorem. Well, Pythagorean theorem, we know, is a squared plus b squared equals c squared. So I can substitute those in and I get y squared plus x squared equals 1. But what I just learned about y and x is that those are sine and cosine. And so what we get to is what we call the Pythagorean identity, because it comes from the Pythagorean theorem. Basically, substituting in for that y and x, I get sine squared theta plus cosine squared theta equals 1. And that's our Pythagorean identity. I'm going to leave some extra space in this box. And we'll come back to that. So please memorize that because you will need it. Alright, let's do some simplifying. Right, let's say I have 1 minus cosine squared. Well, I can look at this, and what I want you to tie this to what I just learned. So I want you to tie this with the Pythagorean identity over here. And how do those relate to each other? What I'm wanting you to notice is that even though I have sine squared plus cosine squared equals 1, well, if I take this and let's say I subtract let's subtract cosine squared from both sides. I get 1 minus cosine squared theta. Hey, that's what I've just been given up here. I could do the same thing going back to this identity. I could subtract sine squared from both sides. Get 1 minus sine squared. So those are just two different ways that we can write the Pythagorean identity, but they all come from sine squared plus cosine squared equals 1. And so just as a little pro tip for you, so anytime you have 1 and a squared trig ratio, you will use a Pythagorean identity. So like 1 squared trig, that's a nice little red flag for you right there to say, hey, use the Pythagorean identity. Take a look at that. All right, so let's do some more examples with that. Let's say I give you sine theta cosine theta over 1 minus cosine squared theta. All right, I look at this. Some people are tempted to cancel out. This is going to be wrong. What I'm about to do is wrong. Some people like to cancel that and they're like, oh, it's sine over 1 minus cosine. Don't do that. Why not? Because I have subtraction going on in here. The reason we cancel is because we're canceling when we have just multiplication and division. Because multiplication and division are inverse operations, meaning they cancel each other out. Division and subtraction are not inverse operations, so I cannot cancel there. So if there's addition going on, that cancels subtraction, but here we are. So what we're going to have to do is I look at the bottom here, and I say, ooh, 1 minus cosine squared theta. That's a red flag to me that says I'm going to be using a Pythagorean identity. And I know that 1 minus cosine squared, if I go look over here at my different ways I can write that, that is sine squared theta. So just a reminder as to what sine squared means. That's like sine theta times sine theta. Now I have only multiplication and division. Because of this, I can cancel out those signs. So I get cosine theta over sine theta. And if you look from last time, that leads us to cotangent theta. And there we have another lovely example. Let's do one more. Let's do cosine theta times secant theta minus cosine theta. All right. I am going to start with distributing. Something that I just want to point out is maybe I could be doing the parentheses first, and I get to this point and go, great. Well, that doesn't get me anywhere because I can't cancel anything because of this subtraction here. So I can't cancel. So that leads me nowhere. So if you try something and you don't get anywhere, go back and try something else. So I tried simplifying just the parentheses. That doesn't work. And so now I'm going to go through and distribute. So I get cosine theta secant theta minus cosine squared theta. Well, cosine theta over 1 times 1 over cosine theta. Those cancel. So I get 1 minus cosine squared theta. And I can look at my list. That's sine squared theta. Cool. Let's spice things up a little bit. I'm going to start with my Pythagorean identity again. There are actually 3 different Pythagorean identities. The one in blue here, sine squared plus cosine squared equals 1, that's the main one. Now these other 2 forms below it are just different ways to write that one identity. So which means I have 2 other identities going on. They all stem from this main one though, sine squared plus cosine squared is 1. And what happens is I'm going to come to this identity and say, you know what? What if I just divide everything by sine squared? Well, that leaves me with, well, sine squared divided by sine squared, anything divided by itself is 1. Cosine squared divided by sine squared is cotangent squared. And 1 over sine is cosecant squared. So that's another one of my identities. I'm just going to leave some space so we can write it in the different forms. And then we also have, once again, starting from sine squared plus cosine squared is 1. I could also take everything and divide it by cosine squared. Sine over cosine is tangent, so I get tangent squared theta plus 1. 1 over cosine is secant squared theta. Sometimes I get some people worry, they're like, how am I supposed to have all these memorized? Here's my secret. These 2 identities I do not have memorized. You know what I do have memorized? Sine squared plus cosine squared equals 1. The reason I only memorized that one is because I know how to get to these ones in green and yellow. Like the one in green, I just had to divide everything by sine squared. The one in yellow, I had to divide everything by cosine squared. And I know my reciprocal identities, and I know sine squared plus cosine squared is 1. And so with those things, I'm good to go. All right, I'm going to take a moment. I'm just going to write the other forms of these. So starting with my green one up here, I'm going to start by subtracting cotangent squared from both sides. So 1 equals cosecant squared minus cotangent squared. And then I'm going to subtract 1 from both sides. That equals cosecant squared minus 1. Going down to yellow, I'll start by subtracting tangent squared. So we get 1 equals secant squared minus 1. And then I'll go back, and this time I'll subtract. Wow, that was wrong. Okay. Secant squared minus tangent squared. There we go. And now I can go back and subtract 1, and I get tangent squared equals secant squared minus 1. All right. So those are just our different ways to write those identities. So let's do some more examples. All right, notice this time I have x instead of theta. I'm only writing it this way to show you that you can have a variable in there, but it acts the exact same as if I had a theta. So I'm going to do the same thing. I look, and before I even get started, I see secant squared minus 1. Squared trig and 1, that is a red flag, ladies and gentlemen. Red flag to use a Pythagorean identity. And so I'm going to come look at my list and look for secant squared minus 1. Oop, there it is. So that gives me tangent squared. All right. Well, I know I have cosine squared x over 1. Tangent is sine over cosine. Those cancel. And that leaves me with sine squared x. Something to keep in mind, there's not just one right way to do this. There are lots of different ways you can do it, and you'll get to the same answer every time. So I'm just showing you a way to do it. So let's do 1 over cosine squared minus 1 over cotangent squared. All right, I can't cancel anything out right now because of this subtraction. So I'm going to change. Another thing, if you have subtraction or addition, that's going to be a pretty good indicator that somehow you have a Pythagorean identity in there. So I'm going to circle that and say, maybe we should take a look at something like that. So let's require simplifying more. That's just to guide my thinking in the right direction. So 1 over cosine. Well, I know 1 over cosine is secant. The reciprocal of cotangent is going to be tangent. Secant squared minus tangent squared. Do I know anything about that? Oh, would you look at that? I do. That equals 1. That's nice. I just want to show you a different way to do that same problem. So if that didn't make sense to you. Let's say I keep the 1 over cosine squared theta. 1 over cotangent, well, that I know is tangent. Tangent is sine over cosine. These two fractions have a common denominator. So just to remind you, if I had 5/3 plus 2/3, that's 7/3. So that would give me 1 minus sine squared theta over cosine squared theta. Hey now, check that out. 1 and a squared identity, red flag. You don't have to draw these red flags, by the way. I'm just doing it because it's fun. 1 minus sine squared. That is cosine, according to my list over here. So I get cosine squared theta over cosine squared theta. Hey, that cancels itself out, and I'm left with 1. Like I said, multiple ways to do these problems. Just gotta pick which one you like. All right, if you have questions, please feel free to email me, reach out, see what you got.